How do blind people see? Probe and examine object, picture object, describe object. For example, blindfold a student. Give the student a meter stick. Place a chair a couple of feet in front of the student. See if the student can identify the chair using a meter stick. When the chair has been identified, turn it upside down, and again, see if the student can identify the chair. How difficult was it the second time? Why?
A magnifying glass is used to see something that is visible but indistinguishable. More detail is needed to describe the object. Use of a microscope. The location of the object and its environment, although unseen, is known. Some training is required for use. The object size is usually only a few millimeters. There are a few, if any, external controls used to manipulate and examine the example. The object may be photographed or digitized for storage on a computer.
Use of blind microscopy, such as an atomic force microscope, actually similar to a blind person with sophisticated equipment. Object sizes here are in the micrometer or nanometer of a meter.
We can use pin picture toys to create a 3D image of an object, such as Chili's face. A mechanical scanner can create images of unknown samples. The probes expose objects row by row, and the scanning rate is determined by how fast you pull the scanner transport. The resolution is very crude in this device compared to the AFM, which can range from 256 lines to 4,096 lines of resolution.
Here we have an AFM, or otherwise known as an atomic force microscope. Notice that the microscope is mounted on a heavy platform, which is suspended by bungee cords to help reduce the interference of vibrations. Then there are cushy padding all around the inside walls of the box to help reduce sound vibrations.
This is a 2 centimeter by 2 centimeter sample. This is the box with the probe holders and the barely visible probes. The student in the laboratory will have already prepared and mounted a similar sample on the platform.
The cantilever with the probe is placed in position close to the surface of the sample. The scanning process is started, and the movement of the cantilever deflects the laser beam as it traces, line by line, over the surface of the sample. This movement is seen by the photodetector, and data is recorded. Notice the line-by-line imaging on the display. This is the same principle that we saw earlier with the mechanical scanner, which gave us a physical image we could see. But, similar to the AFM, the image of the actual sample could not be seen until it was scanned.
After the image has been captured, it may be manipulated for view in several three-dimensional orientations. The image may also be edited so the actual views in surface topography may be determined. There are many irregularities that are not visible to conventional microscopes. The surface is not uniform. The maximum and minimum heights of the surface are below 1 micrometer up to 100 micrometers.